Can you
Test. Oh, can you lower a little bit the speakers? Hi. 1, 2. Yeah, that's good. Let me put it here. Yes. 1, 2. 1, 2. Do you want me to try it on them as well?
Hello.
Oh, on you.
Did you download your Omni bundle? Thank you very much.
I have no idea what you're talking about. Give me 1 second. It's bad when it actually creating these slices will also take time. So it's good that we get started early so we can get you through this. Okay. So first of all, do you all have instructions? Yes. And do you all have a worksheet, which I don't have now to show you, but yes, you have both. How many people are taking the hands-on part? Can we just count a little bit? 1, 2, 4, 5, 6, 7. Okay, so we can give, so is there anyone that does not have a worksheet that would like to take the hands-on part, that is auditing and would like to do it hands-on? Anyway, if anyone wants, yes, I think we have space. Okay, so the first thing, I know we've gone through this before. It will be very helpful if you've done this before. So basically configure Omni as a member of the GEC19 project and know that you're able to SSH from your computer, whether it's a Mac, a Windows, a Linux, you know how to SSH with private keys. If you haven't done this, please raise your hand and Aaron and Luisa will come and try to help you through this. So, okay, so this is a tutorial about running inter-aggregate experiments. So basically, as we said many times, GENI is a federation. Everyone, gives resources to GENI. Everyone has a separate aggregate, and this tutorial will guide you through how you can actually connect resources that are located in different aggregates. So I'm Niky Riga. This is Luisa, and the other guy there is Aaron, and we're basically going to lead the tutorial and help you through it. Okay? So, for those of you that have ever seen the intro to GENI talk, basically, we say that GENI is an infrastructure to run networking experiments. It's a large distributed testbed, and it provides compute resources that are connected in experimenter-defined topologies, right? That's the first slide we usually talk about in the intro to GENI. And then we go on and say that you basically take this very big network, you bring up your slice, right? And you connect your resources together over the network. But we've never really talked about how are these links formed? How are these links between your resources in different aggregates actually formed? And this is what we're going to do today. This is what we're going to talk about today. So most of you, I'm pretty sure, have already run single AM experiments. So for example, in a GENI rack, there's a lot of things you can do just within one rack. Every rack has hundreds of VMs, has a few row PCs, has an open flow switch inside. So there are many experiments you can run and many topologies you can create within just one AM. Now, if for your experiment, it is useful for you to actually span between two racks, right? How are you going to connect the resources, the VMs you have here, the cluster in one rack, with the resources in another rack? How are you going to actually, sorry. Yes, now I remember. Haven't seen the slides for a while. Okay, so how are you going to create this orange link that is there? So before I talk about the options you have there, let's go a little bit back to the GENI architecture. Again, we talked about it, in the very beginning when we introduced GENI, that they're basically, in every GENI compute resource, we have two different paths. We have the control path, like the brown there, and we also have the data plane path, right? So basically, you have options. All the racks are connected through these two different ways. They all connect to the internet over the control path, and they have a data plane connection. So how does that lead us to have what are our connectivity options? So again, we have two different interfaces. We have the control plane and the data plane. And then we have, static configuration. For example, your control interface is always there, right? It's configured, it's connected to the internet, it has internet connectivity. All your compute resources in GENI have internet connectivity, so you can just exchange traffic between your control interface. Now, while you're bringing up your slice, you can also configure GRE tunnels, right? Dynamic. It's dynamic in the sense that you're configuring as you bring it up. It's not already there. So basically, you're still using the control interface, but you're bringing up a different interface that basically tunnels your data plane traffic over the control plane interface. Now, if we go to the data plane, what options do we have there? So there are some pre-configured VLANs that are some static topologies that we have already pre-configured that connect some of the resources in GENI, which then you can just attach your topology in them. And then we have the dynamic data plane connectivity, which we have GENI stitching, which is what the main focus of the tutorial today, because it's something that it's a little bit challenging to use, and we want you to actually get experience while we are here in the room helping you. And there is also exogenous stitching that also provide these capabilities, and I'm going to go over all these options later and give you some idea of when you have to use each one of them. So first of all, if you're using the control plane, I mean, good things is already there. It's already set up. It's tested. It's stable. You know, it's just the internet, right? It's straightforward. The downside is that it has limited bandwidth. So the whole rack has just 100 megabits uplink for all the data plane connections. And it's basically shared bandwidth, of course, with the rest of the internet. So if there's a congestion somewhere, right, your traffic will go through it and you will be limited. It's only layer 3. And many places that they provide, resources to GENI, they're behind firewalls. So, depending on what you want to do, you might run into firewall issues with your experiment. Now, if you want to use the data plane options, you have more bandwidth. It's not, it's not infinite, it's not a lot. In most places, we have a shared 1 gig going out of the rack between all experiments. There are no firewalls, and you can use the hardware OpenFlow switches that GENI has available for experimenters. On the downside, there is limited availability. It's not available in all the compute resources that are right there in GENI. We're still deploying this capability. So there are limited topologies and sites, and it's a little bit harder to set up and use. It's not already there, just working. There are some steps you have to take, and it might be a little bit challenging to set up. So today, in today's tutorial, we're going to use the data plane, and we're going to use the GENI stitching option. So what is GENI stitching? Basically, GENI stitching is a way to set up point-to-point VLANs across the GENI network. So basically, let's say you want to connect the one GENI rack with another. What GENI stitching does is figures out exactly which networks does it have to transient in order to create this data plane connection between your racks. And it goes and creates these links, what we call different stitches, so that you get end-to-end connectivity in the end, right? So this is basically what the GENI stitching does. It's dynamic. It has a real-time setup. There is need to coordinate between many aggregates, depending on how complex your topology is. The number of AMs that needs to be coordinated is bigger. It takes time, and it can fail, right? Because it's dynamic, it has to coordinate many AMs, it has to actually go and configure switches. So there are many different points of failures of things can go wrong while you're trying to break up a stitch slice. It does provide traffic isolation and some bandwidth constraints compared to other options, for example, using your control plane. So today, we're going to use the GENI stitching option, and we're going to use a tool called Stitcher. It's a command-line tool. It's distributed with Omni, which is the GCF and Omni, which is the tool that's why we asked you to install and configure it. It basically is a script that is built on top of Omni. So every create sliver, delete sliver, renew sliver, it's basically using Omni underneath. And it will take care of the path computation that I just talked about. It takes care of the AM coordination and any errors that might come up in the process of trying to build this stitch. So yes, it might fail, but the recovery process is automated within the Stitcher tool. So exactly because it takes time and it might fail, we want to start in the hands-on portion as soon as we can so that we get you going. And now I'm going to pass it to Luisa that will guide you through the first part.
Okay, so what we're going to do is go through and design your topology. We're going to start by going into the Omni portal, and in the portal we'll define a network topology that uses different aggregates. What we're actually going to be using is different sets of racks, and each one of you has a specific set of racks assigned to you to work with. So your compute resources will be in those individual aggregates or racks. And once we define those topology, what Stitcher is going to do, it's going to go out there and allocate your requested resources and set up connections through the potential networks that you see here. All of our resources, network resources, will be going through Internet 2 ION, as well as the Proto-GENI network and MAX. So those aggregates will play a role in us setting up the sliver. We're going to use the information on your worksheet. We're going to be doing things in phases because it's limited resources, as well as we don't want to overwhelm the environment we're requesting and get in each other's way as we set up these slivers. So pay attention to the group number that's on your worksheet. And anyone that's in group 1 will be setting up the first set of slivers. And then once that group is done, we'll be handing off to the next group, and we'll let you know when to start. Now, as we start this, you'll see errors. Don't worry. The tool takes care of most errors, and we'll explain what they are. So if you see them, don't panic. So the topology we're going to get to today is a very simple 3-node topology. And what we're going to do is give you a request RSpec that already has unbound resources, which basically means there is some VMs defined with some links between them, but they're not for any specific aggregate. What we're going to do is import this request RSpec into the FLAC tool, and you get to pick which aggregates do you want to run it in, which racks are you going to use. And we're going to end up with you actually modifying the RSpec that you load into FLAC to use 2 of the nodes within the rack, and then make one a remote that uses a stitched link. And the whole goal of this particular experiment is a very simple one. You'll have both a local link within a rack and a link to a remote site, and you can compare how traffic is handled over both interfaces. So we'll be doing very simple pings, compare delays. For, if you're in the same rack, what does the delay look like? But if you're going across a stitched link that goes across the country to some other rack, what does that look like? We'll also do some iPerf so that you could see what kind of impact the stitched link has over the bandwidth that you can get versus the one that's in the rack. And then time permitting, there's also some layer 2 pings that we can do. Now, I'm going to switch to show you what this looks like. But basically, we're going to log into the portal, launch FLAC, and adjust the topology to make the changes that we need, and then save the files. At that point, we will stop, and that's when we switch to individual groups doing this. So we will be doing this part together first. Sorry about that. Okay, first you can all log into the GENI portal if you haven't logged in yet. And do I have a network? Okay. Once you log into the portal, we're going to create a slice in the GEC19 project. In the worksheet that was given to you, there's a slice name you should use. We give you the slice names because the slice names need to be unique within the project, so please use the slice name that's on your worksheet. Okay, maybe I'll just switch to. Okay, so I'll just talk through. Now that we've completed step 1, we logged into the portal, you're going to go to the project panel. Is anyone else having, okay, project panel. And on that project panel, you're going to select the GEC19 project, or you can just create a slice from this particular level. Create a slice with the name that was given to you. I'm going to be incredibly creative and create a Luisa 1 slice. Create that slice. And now that the slice has been created, you want to launch FLAC. And now there'll be a few minutes to load all the information about the different aggregates that are available to you. I can just talk from the, or wait. Do you all already have the FLAC pane loaded? Because if you do, there's no need for me to wait for this to be done. Okay. Okay, so once you're in the FLAC panel, what you're going to do, there is a pull down called import.
Just 1 second.
So there's an import pull-down menu. If you select the option to import from web in that pull-down, you can load the URL that's listed here. That's the unbound RSpec I was talking about, which basically defines the 3 VMs, but not associated to any particular aggregate. There we go. It's here, import from file. I'm sorry, import from web. And you paste the URL here that you have. Did you get that far? Okay. The first thing you will see is a prompt that tells you that your resources are not associated with any aggregate. You can click OK on that, and now you have to choose an aggregate. What you should do is look at your worksheet, look for aggregate 1, the GENI aggregate 1, and choose that particular aggregate for this first selection. So for the sake of this experiment, my experiment, I'm going to choose Insta-GENI Stanford. Now, you should see in the list of aggregates, there is the name of the site. The second name that you see in parentheses is the actual name that you will see in FLAC. And then the one that comes next at the very end is a short name that we'll use later with the stitcher. So click Accept. And now you have the topology, the unbound topology. But it's now been bound to the rack that we just chose. Now, what we see now is all in one rack. The first aggregate you selected is what all these resources are in. For this experiment, we're going to change the right client to be a remote site. So click on the Info button for the right client. And what you're going to do is pick the aggregate number 2 here. And for my experiment, I'm going to pick Wisconsin. Apply that change. Once you apply that change, you'll see that the LAN is now changed to a GRE tunnel, which is another type of stitching. But for this particular experiment, we're going to select the Info button and modify the GRE tunnel to be a stitched connection. Once you apply that change, you should now have a topology that looks as follows. The right client should be a different color and a different aggregate than your left client. And you have a stitch link connecting your server to your right client.
Pausing for a second. Is everybody keeping up mostly with Luisa? People are having problems? Can you help? So it won't prompt you for the second one?
No.
The first one, so
You have to.
you specify, it prompts you to tell you that your first one, now you have a perfectly good RSpec that you could execute all of them around. Now you're going to edit it, change it, and make it distributed.
Okay. So, and can I continue, or do you want? Okay. So once you modified the right client by clicking on the information button and changing it to the second aggregate, then you change the link to make it stitched. So now we have a distributed topology. Once we're done with this, what we're going to do is export this particular topology into an RSpec file to your file system. Select the View pull-down menu, and you're going to choose Preview Requested Document, and you're going to click on Save it to File, so that we now have the topology that's in this GUI, and we're going to save it to the file system. And please give it a name you can recognize. Make sure you remember where you placed it. Download is a perfect place as long as you keep track of where you save that file. And now, we're going to go back to now we have the topology. Okay, now we've executed all 4 of these steps. and we're at the point where we have the RSpec that we're going to use. Now, this is where the coordinated phase begins. The people that are in group 1 should be able to execute this particular command. We're going to run stitcher, create a sliver. You can use the same slice name that you created in the GUI, and that's on your worksheet, and specify the path to where you saved your RSpec. So please, only the people in group 1 can issue this command. If you installed Omni tools, it should be in your search path. The aliases that were actually the only difference, since I see you have a Mac, it'll be Stitcher without the PY. The alias installed on Mac, remove the PY. So Stitcher, then create sliver, then the slice name that you used, that you created in the portal, which is also on your worksheet, and then the path to where you saved your RSpec when we exported it. And only the people in group 1, please. And you'll see output that looks like this. Please let it run. If you see errors, don't panic. We'll explain what it means. The stitcher will keep trying until it sets up the topology you requested. So I guess the people in group 1 have issued the command. If you need help, please let me know. OK, don't do anything. Just let it run. We'll explain the output. Stitcher is the same as Omni, except it has the smarts to go out there and create the stitch link across all the aggregates. If you were using Omni, you'd have to create the sliver at every single hop. This is smart enough to get your RSpec, look at the component IDs for your link, check with the stitching computation service, how do I connect these two endpoints? And then it generates the stitching RSpec required to set this up end to end. Please. Now that group 1 is running, so everyone in group 1 is now running the stitcher command. I'm ready to turn this back to Aaron. I will stop by in 1 second to look at it. OK, I believe I'm done. People in group 1 should be running. If not, I'll stop by and see you while Aaron keeps explaining what the stitcher is about.
What you were doing up so far.
Did I go too fast?
There's a lot to do. Who else needs help? Okay.
Good? Or?
Excellent.
Okay.
Yep. So I'm going to explain what that's doing in a bit.
Okay.
It looks good.
Okay.
All right. Let's move along. So everybody should have gone through FLAC to take what was a topology in one aggregate and put one of the nodes on a second aggregate, and then save that to a file. And then the folks in group 1 should run the stitcher tool with the command like that up there and start seeing some output like that, plus probably lots of other things. And it looks scary, and I'm going to tell you what's going on so you're not scared. And Niky and Luisa will answer questions if you raise your hand. This process of setting up the dynamic circuit takes a little while, and in particular because it does a couple of complicated things: finding the path, negotiating the VLAN tags that work along the path, and setting up the dynamic circuit across networks like MAX and ION. And you're going to see a bunch of messages, and I'm going to explain why those aren't so scary. But by first telling you a little bit about what's going on in stitching. There's two pieces to stitching. The first piece is the thing that all the network engineers do in advance, and the second piece is the piece that you're doing of actually using all the work of the network engineers. The things to understand is that GENI stitching gets set up in advance by the network engineers for you by configuring all the racks to have a path to the GENI backbone and to the other racks. And this path use VLAN tags. That's the mechanism we use to give you your own private layer 2 network. The other thing to understand is a lot of your circuits are going to go across the ion service, Internet 2. That has its own complications. It's hitting a lot of different switches. It's a lot of traffic coming from other universities. Things can fail, things can go wrong. And so you need to understand that when you watch what's going on in stitching. But basically, what the network engineers have done in advance for you is they've identified a path, negotiating through the campus, through the regional, what the connectivity will be at layer 2 from the GENI aggregate, the GENI rack, to the GENI backbone, Internet 2 in this case. And then you step in once all that's been done. And this picture talks about what the experimenter does to set up a slice. And it's got a lot of pieces to it. But the key thing to understand is most of that is what's automated for you by the tool. And I'm going to walk through in a little bit more detail what it is you do and then what the tool is doing for you. Your job as an experimenter is to define your experiment. If you're going to be doing a stitched experiment, there's a couple things that you need to remember. First, you want a single request RSpec for all of your resources, for everything that you want in your slice. And when you're ready to run stitching, you don't want any of the elements to be unbound. You want everything to be assigned to a particular aggregate. That's what you did when you inputted it into FLAC. You made sure everything was assigned to a particular aggregate. And then you need a link that goes between two aggregates, right? That's fundamentally what makes it a stitched link. And when you're in FLAC, you said, I want this to be a stitched link as opposed to a GRE tunnel. And then if you're just hand editing an RSpec, you just need it to be a link with two aggregates listed. And then you reserve your resources, and you reserve everything all at once. The thing to remember as you do this is that the links that you get are node to node. You're going from a particular interface on one of your compute resources to another interface on another compute resource. We're not supporting multi-point at this time. And then the tool takes over and takes care of all the rest of it. It expands your request to find a path from between your two aggregates, and then it generates a custom request RSpec to each of those aggregates asking for a particular VLAN tag that allows the path to be completed, and then takes all the answers from all the different aggregates and turns that into a combined manifest listing everything that you've got now in your slice. And this is generic stuff using generic aggregate manager API, stitching service. Other tools can do this. In this case, we're using the Stitcher tool. Do you have a real question?
So the Internet 2 also is exposing an API kind of thing?
Yep. Hold off. You're still a couple slides ahead. I want to pause now and see if the folks who started to execute stitching have finished. If you did, you may have gotten to the end. So who was in group 1 who started a reservation? A couple of you. Did you get something that looks like this?
Yep.
Reserved resources in slice? We got one. How about you? Not yet? We got one done, one in process. Who else is running now? You were running. Is it still running? You got the 10-minute thing. We have to wait. All right. How about you? Good. All right. That's good. That's good. Trust me, that's good. All right. Is that it for the folks in group 1? And you're waiting 10 minutes, so you'll be there a while. All right, I'm going to move on.
Try to save the spec. The flash player is just crashed twice. So I'm just trying with another browser, Mozilla.
Oh, yeah, must be something with the browser and Fedora you're using, maybe?
Yeah.
Something weird with the way the JavaScript stuff's working? Yeah, I don't know. Sorry.
Okay.
I don't know how many people have been using it on Fedora. I apologize. Okay. So we've got 1, 2 or 3 people who are still going. They're still creating our specs. You know what I'm going to do? I'm going to keep talking. while people are still creating R specs. You have a question?
When you say in FLAC that you have a stitched link between two nodes, it's just saying that it's going to be stitched, but there are no reservations done.
Right, so in FLAC, when you draw the picture, right, it's just a picture. And then typically you hit submit in FLAC and it does stuff. In our case, we're not doing that for the stitched thing. You're saving that out, and then the command line tool is what's going to go talk to aggregates and make your reservations and set up the links for you.
So what is it that FLAC
What FLAC is doing is it's just generating the XML, the R spec. And yeah, so FLAC has the ability, I'll tell you right now. How's that for an answer? So when stitching runs, it starts out printing a bunch of stuff, and I'm going to explain some of what it's doing, including I will highlight the things which Stitcher does that FLAC doesn't do. First thing that it does is it expands your request. It tells you how to get from Wisconsin to Stanford or wherever your two aggregates were, and discovers, oh, wait a minute, in order to connect these two, I have to go across ion, for example. That is something which, if you hit the right buttons, FLAC can do. It can expand your request. The other thing it does is it gets a little extra information about the aggregates. There's a call called get version that aggregates tell things like, I am a proto-GENI-based aggregate or an extra-GENI-based aggregate. But the major thing is yes. Stitcher is the thing that's on your laptop. It's the command line tool. It's just a Python script. Great question. So, how does Stitcher know the path between Wisconsin and Stanford? The answer is it's that fundamentally aggregates advertise their connectivity. Each aggregate says, I have this switch and it connects to ion, or it connects to Max, or whatever it connects to. And so if you read all those advertisement R specs and followed around, you could construct the graph and construct the topology, and then think about what the optimal way is to follow this path. But there are heuristics that you need to follow to do it right, to optimize your chance of quick success. Luckily, we have the stitching computation service, which is, in NSI parlance, a path computation engine. Its job is to find the path between two aggregates, and it also finds the VLAN tags that are likely to work along the path. Right? You've got two neighboring aggregates. One does VLAN tags 5 to 10, and the other does only 7 to 10. You probably want to use tags 7 to 10, because that's where the overlap is. So this was written by Tom Lehman and Jiang out of Max. You don't need to use it. It's completely optional, but there's also not a whole lot of reason to redo it yourself unless you think you want to compute paths in an interesting way yourself. Yeah?
So when your slide said it was not recommended to use VLAN tag because you might mess it up and get it.
Right, so you can pick your own VLAN tags by constructing your RSpec yourself, but then you have to make sure that you pick the VLAN tag that makes sense at each aggregate along the way. And then one of the things you'll notice is one of the things that happens is sometimes you say, I'd like the tag 7, and the aggregate says somebody else is already using it. And so you'll run into that too. Stitcher does as well, but Stitcher handles it for you. Yeah?
Does ACS serialize requests from multiple users?
Like
suppose me and Paul send a request at the same time. So
Is it multi-threaded?
yeah. Or
Ask G. No, it's not going to give you both the same VLAN tags. Yeah, it's picking randomly from the range once it's computed a range. No, it's not guaranteed. It's picking randomly from the same range. So the language that the Stitcher tool and the aggregates and the stitching computation service talk about these paths, the path between the two aggregates, is this extension to the RSpec. There's a bunch of XML, the stitching extension. And in it, that's how aggregates advertise. I have this switch port that talks to ion. That's how you request, I'd like a path that goes from this aggregate to this aggregate to this aggregate.
And it's how the aggregate tells you in the end, I gave you VLAN tag 7, or whatever it gave you. Other questions? People totally lost? I can't hear you. Oh, is she running one? What's going on?
He was getting that person again and again, got it like 4 times, and so did me. But his eventually, after a whole page worth of the add person error, eventually just came up. Okay.
What are we doing?
I don't know. She told me. Am I supposed to?
No, I thought I was still talking. Who's got a question or a problem? Besides people who are already being helped over there. Since we've paused. Or questions about what I've been saying so far. Yeah, go ahead. I can't hear you. Oh, group 2. Yes, that's a great idea. Group 2. Why don't you start? Thank you for asking. All right, so at this point, in my walkthrough of what Stitcher is doing behind the scenes, you've got a path. And what Stitching Computation Service has done is it's given you a lot more XML. And you can't read this, but what it's saying is that in your link, which used to say, I just want to go between Stanford and Wisconsin, it's now inserted an extra aggregate in the list of aggregates that are involved in that link. And it's added this whole stitching extension that talks about how you get from A to C. You have to go B. So it's A, B, C in your path. And what I keep referring to is that there are these intermediate aggregates that may now show up in the path that you're requesting. These are the regionals and the backbones that run their own aggregates that you have to go across to complete your circuit. One of the things that's nice is that Stitcher will keep track of all those places where you now have reservations. That turns out to be important, for example, renewing your slice so it doesn't expire, or deleting it when you're done. And these are a couple examples of these intermediate aggregates. Internet 2's ION service I've talked about. This is this nationwide backbone for GENI. Under the covers, it uses Oscars, for those of you who've heard about it, which does dynamic circuits. They do VLAN translation within ION. This is an aggregate that Internet 2 operates using software written by the guys at Max again, who run the same aggregate over the Max Regionals network, which again is an Oscars-based network. Who's got a question or a problem? Besides Derek who's being helped. Yeah. Good. You're supposed to get errors. Good. That's good. That's what you want. Trust me. Okay. So when you hit go, and after it's got a path, the next thing that Stitcher does is it goes and reserves your resources. You may see log message that say, Stitcher calling create sliver at, and then gives you a URL, right? Fundamentally, with stitching, it's just doing normal resource reservations. Circuits and VLANs are just resources like compute nodes. They just have a different name. And so the commands that you're doing fundamentally are just the normal reservation commands that you do for other kinds of resources. One difference here is that the order in which you reserve things can matter to how likely it is that you'll come up with a coherent circuit. And I can explain that. But for the moment, trust me that that's something that Stitcher knows and takes advantage of. So the folks from Group 2 managed to start? been reassured that the messages that they're seeing so far are okay? People have questions? How many people are currently watching Stitcher run? Not the folks who finished. Who's watching Stitcher go? You're watching it go, right? Who else is currently running? They're all not listening because they're watching Stitcher run. Who's got questions? Who is listening and not paying attention? Yeah, go ahead.
So in the current topology that we have with the server in the middle, can you make that node become a node to be switched to have it running the same way it works in a single?
So you can make the topology that you started with, right, started in a single rack.
Yes. So do you have in mind the OpenFlow tutorial, the basic one where you have just one controller, one OBS, and then two nodes?
Yeah, I mean, you could do that across, I think. I have to ask Luisa whether she's tried that. Well, if it's going to an OVS box, it's just an OVS box, right? So yeah, right, and it's just you're sending layer 2 packets, and it just happens that the node, your server node in that diagram is an OVS machine.
The stitching thing is in layer 2.
Exactly, it's a VLAN, layer 2. Exactly. As long as you don't touch the MAC addresses or the VLAN tag on the packets, have fun. Exactly. It sends two things. It sends back an expanded request RSpec, adding in particular that stitching extension, and it sends back some workflow information, essentially saying this switch hop depends on getting VLAN tags that are picked by this other one. Yeah, this ought to sound familiar to you guys. They're not an accident. Go ahead. You have another question? No? What's it? Oh, yeah. Good. Other questions, problems? Yeah, go ahead. Keep going. That's what I'm here for.
That's the whole thing that I've been confused for a while. When you're in flat, you have a lot of possible racks to pick from. Is it relevant which one you pick for the kind of experiment that you want to do?
Sure. So for example, there are some differences between exogeny and instageny racks. In general, there are more instageny racks, but they tend to be smaller, have smaller disks, that kind of thing. There are fewer exogeny racks. They tend to be beefier machines. That's like 10,000 foot level. But if you're looking for help in picking racks, that's the kind of thing that if you've got a particular experiment in mind, you can email help@geni.net, and folks can guide you. In particular, point you to some of the documentation on the different kinds of racks. You know, the full hardware specifications on the racks and that kind of thing. We can talk about differences in capabilities. Connectivity might turn out to be an important difference for you, for example. Other questions? I'm going to keep going. How's it going? Good. Oh, that's different. Do it again. Okay. I don't know if you've been following, but they're getting tons of these add person to site errors. Yeah, that's what his problem was there. Ion gave that add person to site error out of the Ion aggregate. You know, somebody back there saw it 5 times in a row. Same user, same slice, same project. Yeah, I don't know what that is. Yeah. Great question. Yeah, Stitcher handles it. Stitcher will handle it. Yeah, I'll explain exactly how. All right, I'm going to keep going for the people who aren't watching something going. So what happened when you send your request to the aggregate? The aggregate first makes sure it's got available the thing you asked for. You asked for a particular VLAN tag. It makes sure that that VLAN tag is available. And then it configures the nodes and all those things. It also configures the switch to wire up that VLAN tag so that it reaches your interface on your node. And then it sends back the manifest RSpec telling you what you got, just like for other resources. So let's talk about errors. What happens when things go wrong? Because things do go wrong. I'm answering Paul's question, but he's busy. What happens if the VLAN tag that you asked for is already being used by somebody? You get back an error. This is one of the things that FLAC does not do. Right? You get back an error and saying that the VLAN tag is in use or that there are no more VLAN tags available. Stitcher knows how to interpret that. Says, oh, the problem here isn't, nothing's going to ever work, die. But if I just picked a different VLAN tag at this aggregate, things would work. And so that's when you'll see in your error messages something about pausing for 30 seconds. It's trying a different VLAN tag. You tried one VLAN tag, it didn't work. Now it's trying a different one, and it'll keep going. And Stitcher has some smarts to understand. There are different kinds of errors. Some kinds of errors it can't recover from. You asked it for an ExoGENI OpenStack VM and send it to an Insta-GENI rack, it's just never going to work, and it gives up, right? Some of these kinds of things. People have been seeing some funny add person to site error that's happening too many times. If Stitcher doesn't know how to deal with it, it gives up. But certain kinds of things it does know how to deal with, and it tries again. If Stitcher tries a path and the VLAN tag doesn't work, it picks itself. It doesn't go back to the stitching computation service. It tries right away because it knows what the range was of VLAN tags that are possible. It gives back both. It gives back both. It says, try tag 7, but tags 5 to 10 are possible. And then Stitcher will pick a tag, another tag in that range, remembering not to pick 7 again. For your case, somebody else might still pick 7 again. SCS just doesn't pay attention to what else it's doing. SCS just says it's physically not possible to get from A to C unless you use tags 5 to 10. It might be that right this second, all of tags 5 to 10 are in use. But the stitching computation service isn't accounting for that. So what Stitcher does is Stitcher looks at what works at the different aggregates, and it goes through the list and tries different tags, picking randomly amongst. The only state of what's available, what's in use, is at the aggregates, basically, right? And the trick there is that state tends to be dynamic, right? So you have to ask right then. So in a future iteration, Stitcher may do more of that for you to be a little bit smarter about what it asks for, but doesn't at the moment. It just keeps going down the list and trying until it runs out of tags. And at some point, it might run out of tags, in which case it will go back to the stitching computation service and say, is there any other way to get from aggregate A to aggregate C? Because I can't get there this way. And then there may be answers, depending on if you're going through Protogeny Utah, for example, that has a lot of connectivity to the internet too. There may be alternatives that it can use. So we don't do multi-point. So you yes, it's in the plans, but I don't know. I can't tell you what the time frame is. Part of the problem is what gets supported by the networks in the middle, right? So Niky's going to talk at the end about things other than stitching that you can use to connect between two aggregates. She talked about the control plane, right? Just public internet, and you can create GRE tunnels that go over the control plane, and that's another way, right? So you saw that GRE tunnel was an option in the drop-down list. Those are the basic options that you get using FLAC for connecting resources to two different aggregates. Sure. So a GRE tunnel going over the data plane versus the private VLAN that you get over the control plane. You get different kinds of control over the topology. You get more bandwidth control, potentially higher bandwidth. Right? You only have 100 megabits that you're sharing for all the control plane traffic on the control plane, whereas the data plane's typically a gig. But Niky's going to go through that. She's got a slide later to compare some of the options. Yes. I mean, so the question was sort of, can I just draw my own topology in FLAC and then draw some lines, use the drop-down, change the link type to be stitched? Does that work? And the answer to first order is yes. But as Niky mentioned, the sites, the aggregates that support stitching are limited, and FLAC doesn't know what that list is, but there's a wiki page that does list what all those are. If you know what these two aggregates support stitching, yeah, have fun. Draw a crazy topology, draw some links, put your own custom disk image, all that kind of stuff, absolutely. Yeah. Who else has problems or questions?
Who has successfully stitched so far? 1, 2, 3, 4, 5. Who is still waiting for a ball? To a ball, or you're waiting for Stitcher? Stitcher. Who is waiting on Stitcher? Oh, cool. And who wants to run?
Who hasn't started? Who wants to? Everybody's run? We were trying to use the balls. If you're holding a ball, then you're allowed to start. Limiting the load in particular on the ion aggregate. The ion aggregate, the aggregated internet 2. Yeah. Because ion aggregates, dynamic circuits, run into problems. One of the things that's happening when you're making a reservation across ion is it's configuring a whole bunch of Juniper switches all across there. That takes time. You got 3 different requests trying to write different configurations into the switch. You can run into conflict. If you space them out, it's happier. So these are some of the errors that you'll see, particularly when you're reserving at the ion aggregate. One of the things that Stitcher does is it knows that a lot of the ion aggregates are transient because it was just 2 different things trying to reserve at the same time. So if it waits a little bit and tries again, a lot of those ion errors go away, and so it does that. And you will see a lot of error messages, but don't panic, right? For those of you who have seen it succeed, it does succeed. Give it time, right? But it will succeed. There's a whole list of a lot of what the common error messages are at the end of this slide deck, and also on the wiki. There's a Stitcher web page. The link, the URL's up there. And that lists a lot of the error messages that you'll see when you're running Stitcher and what they mean. In particular, telling you, this is one that's fatal, there's something wrong with your request, or this is one where Stitcher's going to try again if you just give it a minute. And here's an example, right? There's output like VLAN tag 1712 for stitched 4 not available, right? You were asking for tag 1712 on your link that you named stitched 4. Somebody else is using it. Request was unavailable, right? We'll put this aggregate back in the pool to allocate. It'll go back, it'll try it again. And then it pauses just to 30 seconds to make sure any intermediate state that the aggregate had gets cleared up before it tries again. That's a pretty common thing that you'll see because it does have to go through and find tags that are available. At the end of all those error messages, when Stitcher keeps retrying, you will get results back. And the results of what you get typically aren't the Stitcher details aren't typically that interesting. You usually don't care what the number is of your VLAN tag. But it's in there. It's in the manifest. And you'll have a manifest that's got a couple of different components, and you'll have that stitching extension. And the other thing that Stitcher does is it gives you an XML comment at the top of your manifest RSpec telling you, these are the aggregates that you have resources at, right? On the path, the link that's got this name, right? At this interface, particular switch, particular port, I'm using VLAN tag 992. All that gory detail is in there to tell you the full topology if you're interested. Yeah.
So it's for reserving resources and connecting those resources, creating the links between them, right? What we did in the Slack was just change one of the links to stitch, right?
Right. First you did is you changed the aggregate for one of the nodes to be at a different aggregate, and then you said you wanted that to be a stitched link as opposed to a GRE tunnel or something else that wouldn't work. And now you've got a request that says, I want to go between these two resources on different aggregates with a stitched link. Give me a VLAN.
Okay, so does Stitch reserve the resources on those aggregates too?
Exactly. Everything gets reserved for you all at once. So right now, when we get to this point, Luisa will show you, you can go log into those nodes that you've just reserved. They're all set up. Your SSH keys that you had on the portal are installed. Everything, that RSpec had an install script, so there's programs now running on those machines, all of that. Yeah. One of the key things to remember is it's just resource reservations, right? Stitching is just resource reservations. If you've reserved resources at an aggregate, you've done most of what's involved in stitching. The only difference is you're also asking for a VLAN connection to one of those nodes. Everything else is just like resource reservations you've done before. One of the things that we did in this when we set this up is we started with an RSpec within a single aggregate. And that's something that you ought to try to do. Make sure it works within a single aggregate before you try to go across multiple aggregates because you're just introducing variables and complexity. Ask questions, right? We've got this user group, right? It's fairly active. You'll get to the right people who can answer your questions. And something goes wrong, you don't understand what Stitcher's saying, send us all the output, right? And we will answer, right? You'll get to us again. But we also need to know, I've been trying this topology, and I really need 6 links that go to Stanford, and there's never enough VLANs. That's interesting information to us, because then we can go work with the network providers to get more resources. Use FLAC like we did here. It's a great way to create an RSpec. It's easier than editing XML. Well, I edit XML, but for most people, FLAC is easier. Bandwidth, I'll talk about that. Start with the default bandwidth, but you can play with the amount of bandwidth that you get. And we'll talk about renewing and deleting using Stitcher as well. So the capacity, you can specify the capacity that you want on the circuits. And you're asking just for nominal, right? You're not getting a guarantee. But by default, if you don't specify, you're going to get 20,000 kbps, literally, about a 20 meg pipe. And you can modify that. But if you're going up too high, remember that most of the links are about a gig. And so we prefer that you coordinate with help at GENI.net if you're asking for a lot of capacity on one of these links, because you're going to be denial of servicing other experimenters on that link. Renewing and deleting. You've set up your thing. It's great. Don't forget to renew it before it goes away. Point 1. Point 2. You've got stuff at aggregates that where you didn't originally request stuff. Right? You have resources now at ION or at Max or Pudgini, Utah. A very common error is people forget to renew the resources there, and then I had stuff that worked yesterday. How come it doesn't work today? Because your circuit across ION expired. Stitcher will remember where you've got stuff. It writes to the local current working directory where you ran Stitcher a file that just lists all the aggregates in that slice. So if you run renew, like something like this, from that directory, it will go contact all the aggregates where you had resources, and you can renew them all to the same date. That's also a great way to clean up when you're done. All right, who's still watching Stitcher run? Three people? Let's see what you got.
Didn't like me for some reason.
So you're getting that one, which is crazy. That's not supposed to happen. It's a bug in somebody's aggregate. But these are the standard ones, right?
Yep.
You tried that one. It wasn't available. Let's try it again. And that's just contention because there are a bunch of people using standard.
I'm happy that it'll work eventually. Can I Control C and abort it, or is that going to break something in the middle?
If you do, you should do a delete, just to make sure that anything it has.
I had to do delete first before it even worked. I had to go and delete everything.
Yeah, you don't need, you can do the delete command line,
Okay.
right? Because right now Stitcher already knows where it's requesting stuff, right? So just like I showed for a new sliver, you can do that delete sliver.
Okay.
Getting this error message.
Which,
This thing.
yeah, it's a bug in the aggregate. I don't understand why that's happening. It's not supposed to happen. Ah, but it finished. You got your circuit. You're all done. You have a full slice. Patience is a virtue in stitching. So it kept trying. You now have a full circuit, right? Your circuit number, according to Internet 2, has that number. Everything is complete. You now have 3 aggregates, including one intermediate aggregate that was in the original request.
Okay.
Everything finished successfully. Good. I know. We're going to keep going. All right. Who hasn't run? Is everyone run now? Everyone's run or finished running? There are a couple people who are still running, but everybody started, right? All right. Niky, do you want to come do these slides? Or do you want me to do that? I can read them if you want. I don't care.
Okay, so put this here. Okay, so now I'm going to talk a little bit about other options. So again, we're in the early stage of deploying this to the racks out there. So it's not supported universally. You have limited sites. There is still a limited number of available VLANs. So if many people are using it, you might have trouble finding sites that will have available VLANs. If you have a very complicated topology, it might be hard to get up because you see all these errors. If it's very complicated, it might take some time to be able to debug all the things and make it work. So we are trying to make this, more robust, more stable, and widely available. But in the meantime, you do have some other options depending on the type of experiments you are running. So if you remember, I talked before about the control plane, the data plane, and the different other options. We've already talked about this GENI stitching, which is what you're using now. So I said before that you can use the control interface, right? And basically, you can use the internet connectivity of your nodes to run your experiment if you have light traffic. So don't go, and try to send 1 gigabit on the control interface and basically, lock everyone out of the rack because you're sharing the same control interface as everyone else. But you can use that. If that's an option to you, for example, if because you do want to run your experiment in the wild and you do want to have competing internet traffic, another very good option to run your experiment is Planet Lab, right? Which basically this is what it's there for. It has many more resources around the US and the world that actually provide this internet connectivity between your nodes. Another option is to use GRE tunnels. And what are GRE tunnels? They're basically encapsulate the traffic and send it over the control interface, so it's over IP. It gives you the impression that you are on your own private VLAN and your own private subnet, and your hops are just 1 hop away. So independent of how many IP routers you pass in the middle, to you it would look like just 1 hop. It does create a separate interface on your nodes. So when you're using the control interface, everything goes through the same interface as your management traffic. This will still go through the same physical interface, but you can manage the interface separately. So if you want to, if you want to introduce some losses, if you want to shape traffic, if you want to do traffic shaping in that interface, you can. If you want to bring it down or up, that won't affect your control interface. Right? So GRE tunnels are another way. So in Proto-GENI AEMs and Insta-GENI AEMs, this can happen automatic for you. So just like you drew a link in Flag and you said, I want this to be stitched, you can say, I want this to be a GRE tunnel. And depending on the type of resources you are using, you can either have a GRE encapsulation that is transferring IP traffic inside or Ethernet inside. So basically, if you're using OpenVZs, then you get the GRE with IP inside. If you're using Xen VMs, then you get Ethernet inside. And the two GRE tunnels, of course, does not talk to each other. One carries layer 2 traffic, the other layer 3. You know, they cannot talk to each other, right? So they don't mix and match. And they are a separate data plane link type in the RSpec. So, I mean, I know the font's a little bit small, but the basic thing here to see is that the link type is just a link like any other link you will have. Like the stitch link you were creating now, it has two component manager IDs, and just the type instead of LAN is GRE tunnel. And this is how it would look in FLAC. You just draw two nodes, you draw a link, and you choose for this to be a GRE tunnel. Now, what if I talked about these pre-configured VLANs. What is that? Pre-configured, they're layer 2 topologies that you can attach your experiment at. So we've already made these topologies, and they're out there available. And the only thing you have to do is basically reserve your nodes and attach to these pre-created topologies. These topologies, of course, are static. The bandwidth is shared. All of them are layer 2. You have the option of OpenFlow enabled static topologies, which you might have heard as mesoscale. This is like a static VLAN that has like OpenFlow switches in the path. There are non-OpenFlow VLANs that we have set up. This is both basically for the future Internet architecture teams so that they can run their experiment being all in one VLAN. It has high repeatability, but if you want to use any of that, it's good to coordinate with us because there's a limited number, and depending on and because they're shared between experimenters, we have to coordinate how we're going to separate the traffic on these VLANs. Now, how do you use the pre-configured VLANs? Is again the same RSpec as before. You have like you have a link, and there the only thing you have to say is specify a specific RSpec tag that says the name of the shared VLAN. And if you go to FLAC, you basically draw a LAN, and then you go and say which of the shared VLANs you want to use, and that basically attaches any node to the shared VLAN. You don't need to have more than one node, because in one aggregate, you can only choose one VM and attach it to the shared VLAN, and then you get connectivity to another VM at another aggregate. Okay? Now, we talked about GENI stitching. We said in the beginning that there is also the exogeny stitching. This basically works across multiple network aggregates, AL2S, ESNet, ION. Is integrated with the exogeny operation as part of the topology embedding. So I don't know if any of you have used exogeny, but you can submit a topology to what they call an ExoSM, which is a central aggregate manager that manages resources in all the racks. And then it will do some topology embedding for you, and this is part of this service that is running there. It also supports that you can stitch not only to another rack, but you can have like external stitching. For example, to your lab, you can specify a stitching point to external resources to GENI. You can stitch to storage devices if you want. And what you see here is a screenshot of an exogeny-specific tool called Flux. Now, how can you use the exogeny stitching? You can create any topology between any two only exogeny racks, so this does not work with the insogeny racks. And then, if you see the RSpec there again, it's a plain old link. You have two different component managers for the two racks, and the type is LAN, just like you would do in normal stitching. Just instead of submitting it through Stitcher, you give this RSpec to ExoSM. So ExoSM, again, is a special aggregate manager that has a view of all the racks and manages resources from all the racks and can do this topology embedding for you and go and talk to all the intermediate networks and create the stitches for you. You can use it with GENI tools, both with Omni and with the GENI portal. FLAC does not know how to do the separation between an RSpec that is bound on some racks but submitted on ExoSM. So you cannot do this with FLAC. You can, of course, also use, if you use the GENI tools, then you have some limited options in terms of exactly what you can stitch at. If you use the exogeny tools like Flux, which is a native exogeny tools that works with all the exogeny racks, then you can have this full range of and power of exogeny stitching. You can find more information there. And you can use this option when you know your experiment is fully contained within exogeny racks. This is probably the best way to connect your resources. Okay, and this is just a summary slide that has all the different connectivity options, just as to To remind us, you can go to control plane. Remember, this is shared with your control interface, so you don't want to bring this interface down. You won't have access to your nodes. You can choose the data plane. I believe the more dynamic option of all the things you have in the data plane are like stitching, whether GENI stitching or exogeny stitching. One, GENI stitching is widely available. It will connect all the GENI resources. So that will give you great flexibility in terms of the topologies you can instantiate and what you can do. Yes?
So if we want to connect resources from outside, we should connect it to exogeny, right?
Non-GENI resources?
Yes, non-GENI.
There's a couple of ways that can happen. Exogeny has a mechanism for doing that, but there's also an equivalent mechanism in GENI.
Okay, so
We can talk about that.
if we have say aggregates on exogeny and intergeny stitches, and we want to connect it to outside resources, we should connect it to exogeny, right?
If you have stuff in both exogeny and intergeny, then you don't want to use exogeny stitching. You want to use GENI stitching, because exogeny stitching can't connect to intergeny resources.
Both GENI stitching and exogeny stitching have a way to define external points that are not racks. They're different ways. I don't know which is easier or harder, but it's basically, I believe in exogeny, you also have to do something manual, right? To define external stitching points. Yeah. GENI stitching. Yeah. And I mean, I don't know if they're doing it this time, but in many of the exogeny demos during the demo nights, they usually stitch to the demo floor, right, which is an external point. Okay, so now, how many people have not brought the slice up and they're still seeing errors or anything? No? Everyone, you're ready to do in the example? Okay, then I'll wait for Luisa to guide you through the actual application.
Can you hear me now? Now we're going to execute the next part of the actual experiment. And first, we'll be executing some pings from the clients to the server so that you can compare the different timings that you get over the different kind of connections. I had created a sliver earlier, and my sliver was between Stanford and Wisconsin. So I'm going to get the login information for the left client by checking Stanford, which was the left aggregate that I was using. Okay, and here you see that there's two sets of login information. One is for the left client, right here, and the other is for the server in the middle of the topology. So we're going to use the first window to connect to the left client. And also the second window I'm going to use to connect to the the right-hand side client, which was at Wisconsin. So I'm going to get the login information. So there's my login information for the right client. Okay. So on the left client, which is using the local link, I will show you. So once you've on the left client, I'm going to use the interface that's associated with the data plane, in this case 10.10.11, to ping the server, which is 10.10.12, and I'm going to send 10 packets.